Hello everyone, welcome to my YouTube channel. So today we are going to solve advanced level question that I have taken from a Pathfinder. Let's read the question first. To whirl a stone tied to a cord, one has to move the free end of the cord on a circular path, pulling the stone on a larger circular path. In this way, stone of mass small m is whirled on a horizontal circular path of radius capital R with the help of light inextensible cord of length small l. By moving the free end on a circular path of radius small r with a uniform speed v as shown in the figure. At sufficiently great speed v, tensile force in the cord becomes so large that the effect of gravity can be neglected. So we can neglect the effect of the gravity, but at this speed, air resistance becomes considerable. Find the suitable expression for the force of air resistance according acceleration due to gravity is g. Okay, so let's analyze the situation. There is a stone of mass m which is tied to a string of small l length and which is attached to a hand, right? So this stone is whirled in a circular motion, right? Somewhat like this. So stone is moving in a circular motion, right? And at the same time my hand is also moving in a circular motion of small radius r, right? In this case we can neglect the gravity, but my air resistance becomes considerable and I have to find a suitable expression for air resistance. Okay, so this was my given question. In the question you can see the stone is moving in a circular motion, right? Let's say the angular speed of this stone moving in a circular motion is omega, and my hand is also moving in a circular motion, right? Right? So if you see, the time taken by hand to complete one revolution will be same as time taken by stone to complete one revolution. So my angular velocity of rotation of hand will also be equal to omega, right? Both has to be equal, then only if my hand is completing one revolution in t second, stone also has to complete one revolution in t second, right? So I can say that omega of hand is equal to omega of stone, right? So omega of hand can be given as v upon small r, and omega of stone, if I take velocity of stone moving in a circular motion as u, so I can write omega of stone as u upon capital R, right? So if I equate, since omega of hand is equal to omega of stone, I can write v upon small r is equal to u upon capital R. From this I can say that u is equal to v small r, v upon small r times capital R. Let's call this is my equation number 1. Okay, let's see what are the forces acting on the stone now. If you see, there is a tension force due to strain on the stone, and there is a air resistance acting on the ball which is trying to resist the motion. So somewhat like this. Let's call this force due to air resistance as Fa. Force due to air. Okay. So these are the forces acting on the stone. So if you see, I can take angle as theta between small l and capital R, right? So this was my stone. There was a tension force acting on the stone T. There was a resistance due to air, and my angle that I've taken was theta, right? Okay, this becomes my T cos theta. Vertical it becomes T sin theta. So if you see, my T cos theta is providing me necessary centripetal force to move in the circular motion. So I can write T cos theta is equal to mass of stone times omega square times capital R. right? Centripetal force, right? So my t cos theta component is providing me necessary centripetal force, right? And this mass was moving with uniform velocity u, right? So I can write my t sine theta minus fa is equal to 0, since mass is moving with uniform speed that's given in the question, right? So in this equal to fa, right? Okay. Okay. If I take the ratio t cos theta and t sin theta, I can write t sin theta upon t cos theta is equal to fa upon m omega square times capital R, right? If I take the ratio of this and this, right? So T cancel, sin theta upon cos theta, that becomes my tan theta, that is equal to Fa m omega square times R. From this Fa I can write tan theta times m omega square times capital R. But I still don't know about theta value, right? So I have to establish a relation. Okay. So if you see in the triangle, let's name the triangle. Let's name the triangle as A, B, C. Okay. If you see in the triangle ABC, if you see in the triangle ABC, okay, if you see in the triangle A, B, and C, this is my small r, this is my L, and this is my capital R, and the angle is theta. Okay. If I apply cosine law, right, so I can say that my cos theta value will be equal to L square plus capital R square minus small r square upon 2 LR, right? From cosine law, right? That gives me cos theta equals to A square plus B square minus C square upon 2AB, right? Okay. So from this, I got the value of cos theta. So I can say, and I know that my tan theta value is equal to sec square theta minus 1, because tan square theta plus 1 is equal to sec square theta, and this tan theta value can further be written as square root of 1 upon cos square theta minus 1. If I put this value in the above equation that I got, okay, if I plug in this value tan theta here, I can get the value of fa, right? So if I put the value, I can write fa is equal to under root cos square theta minus 1 times m omega square capital R fa, and I got the value of cos theta. So this becomes square root of 1 upon L square plus capital R square minus R square whole square. Denominator will go up, that becomes 4 L square R square, and this is minus 1. M omega value I had V upon small r, right? So omega, if I put it here, this is V times small r whole square times capital R. So my Fa value, if you see, this becomes square root of 4 L square R square upon L square plus R square minus R square whole square minus 1 M V square upon small r square times capital R. So this is my final answer.